Imagine you're driving a car and you traveled 60 kilometers in 1 hour. Now, if I ask you what was your speed, you're probably going to answer 60 kilometers per hour. But what if I ask you what was your speed at 43 minutes 43 seconds exactly? Can you answer it? You probably cannot, right? Because the answer you gave me, 60 kilometers per hour, it's an average speed. But average speed cannot help you to find the speed of an exact moment. That's where differentiation comes in. And today's topic is differentiation. Today we're going to learn everything about differentiation. Primarily, differentiation is a mathematical tool which can tell us information about an exact moment and also how fast something is changing. So differentiation can give us to measure information. First of all, how fast something is changing. In other words, differentiation tells us the rate of change. Now, what does rate of change means? Rate basically means the change that is happening in unit time. Now, unit time means it can be 1 second, 1 minute, 1 hour, 1 day, or whatever in one unit, right? So, first of all, it says how fast something is changing, how fast or slow something is changing, and that means that the rate of change, right? For example, let's say distance is changing and with respect to time. When you say that in per unit time, that means with respect to time. So when distance is changing with time, what do we call it? We call it speed or velocity, right? So we can say v equals to d divided by t, right? So when distance is changing with respect to time, we get v. In that word, we can say that if we differentiate a distance with respect to time, we are going to find velocity, right? So differentiation of distance with respect to time gives us velocity. Just like that, we can get also acceleration if we differentiate v with respect to t, right? We will use another symbol pretty quickly, but we'll come to that later, okay? Now, the second information, another vital information that we can get from calculus, from differentiation, so which is maximum and minimum. Now, differentiation can tell us where the maximum point is, where the minimum point is. But how does that help us? Let's say you have a business. You want to know what input will give you the maximum output. So you can use differentiation. Again, you want to know the risk. You want to know what input will ruin your business. That means give you the minimum output, right? That's why differentiation helps you. It can tell you where the maximum is and where the minimum is from a graph. But we'll come to that later with some maths too. Now, we are almost done with the differentiation theory. So we can just hop into formulas. Let's start with the power rule. Before going to the power rule, let's see how we can symbolize differentiation. Let's say we have a function y equals to something. Let's say that's 3x plus 2, right? Now, we want to see how y changes with respect to x. Now, we symbolize is d divided by dx. So this is a function, and we are trying to differentiate y. That means the change of y with respect to x. Now, how do we call it? We call it d dx of y. D dx, which is the function, and y, what will be changed, right? So you're going to call it d dx of y, d dx of y. Sometimes it also called it dy by dx, just for that. Now, let's start the power rule. Now, power rule says that, let's say we have a function y equals to x to the power n. Now, we want to find the difference, we want to differentiate this thing, okay? So, we want to find d dx of y. That basically means the change of y with respect to x, right? What's going to happen is this power is going to come in front. So, it's going to be nx and the variable stays there. And the power is also going to get reduced by 1. That means n minus 1. So, basically what happens again, the power is coming on the front and also the variable stays there and the power is also getting reduced by 1. That's the power rule. Whenever we have something like this, we can change it or differentiate it like this. For an example, just for an example here, let's say we have a function y equals to 3x squared. Now you want to find the differentiation of this one. So dy divided by dx, d dx of y equals to, what did I say? The power will come in the front. That means 2 will come in the front and 3 is already there, it stays there. The power on the variable, that means the power on x, will be reduced by 1. So simply 2 minus 1, you get the result of 6x to the power 1. We don't want to include 6, the 1, power 1. In example 1, we have a question y equals to minus 3x to the power 5. We have to differentiate y. Let's see how it goes with the power rule. First of all, we have to write it dy by dx. Now, according to the power rule, what happens? 5 comes in the front, right? Our constant stays there. Minus 3 is already there. 5 comes in the front. Here's the 5. And then the power on the variable is reduced by 1. So 5 minus 1. That's it. Now you multiply, you get minus 15 x power 4. You don't always have to write it like this, breaking down everything. When you become an expert, you can just do it in a single line. But for now, we are going to break it down just to understand clearly. Okay, now let's move on to example 2. Now we have y equals to minus 2x to the power minus 6. We have to differentiate it. So again, dy divided by dx. What happens is you write the constant first, the minus 2 is there. Minus 6 will come in front. So minus 6 coming in front. Your variable has the power, it will reduce by 1. And one common mistake is that we think that minus 6 will just become minus 5 and it is reduced by 1. That's not the case. Minus 6 is smaller than minus 5. If you reduce it, it's going to be minus 7. We have to be careful about that, right? Okay. Now, let's multiply them. Minus and minus, when you multiply negatives, you get a positive. So it's gone. 2 multiplied by 6 is 12. And x has a power minus 7. So that's it. If you have a negative power, you differentiate like this. Now we have a fraction in our function, right? Y equals to 4x power 7 divided by 5. But nothing to worry about, just the same system. So let's do it. So we have dy divided by dx. Same thing, you write the fraction without the variable. What's the fraction without the variable? If x to the power 7 is not there, we have 4 divided by 5. And as we know, according to the power rule, the power will come in front, right? So 7 comes in front, and the power of the variable reduces by 1. That means minus 1. That's it, nothing else. So 4 multiplied by 7, we cannot actually simplify anything here. So 4 multiplied by 7 is 28. That is divided by 5. And we have the result as x power 6. So simply you can put it like this, 28x to the power 6 divided by 5. So that's your answer. Pretty simple, right? Now, we have the exact same question, 4 divided by 5. One thing has changed, that is x to the power 7. From a numerator, it has come down to be a denominator, right? How do you solve it? Okay, first thing first, we have dy by dx. But before coming to this line, I want you to do something else. We will never differentiate it in this way. First of all, we want the variable as the numerator. Doesn't matter what happens to the power, we want the variable as to be the numerator. We do not want our variable to be a denominator. So let's just change it. What can we do? We can write y equals 4 divided by 5 x power minus 7, right? So x to the power 7 was the denominator. When we brought it up, that means we make it numerator forcefully. Now the power is going to be inverse, right? So x to the power minus 7. Now it has been converted into a numerator. Only then we are going to differentiate it. So whenever you have the variable as denominator, the first thing you are going to do is to get it to the numerator part. Then you are going to differentiate it, not before that. And do not worry about the power, right? We know how to differentiate when there is a negative power. So no worries at all. Again, last time, whenever we have the variable as the denominator, we are going to take it forcefully to the numerator. Then we are going to differentiate it. Now let's differentiate that thing. So what's going to happen? We write whatever we have already. Then we bring the power in the front. That's the power rule. And then we write the variable and we reduce the power by 1. That's it. Pretty simple, right? So 4 divided by 5. When you multiply, it's going to be minus 28 divided by 5, and x is going to be powered minus 8. So that's it. Again, once again, if you have the variable as denominator, just make it numerator, then differentiate it. It's easy peasy. Okay, so it will be example 5, right? Okay. So in example 5, we have a big equation. Now, can we solve it? We obviously can. We know everything that we need to know to solve it. Let's do. So dy divided by dx. We are going to differentiate each one of them with the power rule. What happens? The minus 2, the 5 is there, then the minus 2, that means the power comes in front, right? We know it. So minus 2 is there, then you have the variable, then the power is reduced by 1. Done. Let's keep it that way. Then the plus, the sign in there. So what's the power on 6? It's not 0, obviously. If it was 0, then it would be just 6, right? So x to the power 1, when we don't have a power, we have to assume that there's a power 1. So 6 is there, 1 comes in front. We don't need to write it. I'm just writing it to make you understand clearly. Then the variable x, and then 1 was there. We are going to reduce it by 1, right? That's it. Now let's move on to the last one. What's the problem here? The problem here, we do not have any variable. We do not have a variable. What does it mean? If it means that we have a variable with a power 0, right? That gives us only 2. Now this power comes in front and gets multiplied with 2. It makes everything 0. So whenever we have something with a variable, we do not need to differentiate it. It's just 0. So we don't care about it. It's just gone. Okay. Now let's see what happens. So 5 multiplied by minus 2 is 10, minus 10, and then x as a power minus 3, minus 2, minus 1. Then the plus, and 6 is there, and then x to the power 0, right? 1 minus 1 is 0. Now we know that when something is power 0, it just becomes 1. So plus 6 only, we don't have the x only. See, it was a little bit of bigger equation than the previous questions, but it's the same thing and we can solve it very easily. Now in question 6, we have a big equation, but that is not the only change. There's another change. Can you spot it? Yes, it was dy by dx until now. Now it has become dx by dy, but why? You can see that now the equation is x equals to something y, right? That means we are calculating the change in x with respect to y. We are changing y, then the x will change. X will change depending on the y. That's why it's dx divided by dy. In our previous questions, we have y equals to something, then x will change the y. That means y will change depending on x. That's why it was dy divided by dx. Let's say it's x plus 3. Now we write it dy divided by dx or ddx of y, because y will change depending on the value of x. That's why we are dy by dx. But here we are doing the opposite thing. When y will change, x will change. That's why you cannot write dy by dx, we have to write dx by dy. Remember, not all the questions will be y equals to something, you just write ddx of y. There can be different symbols, different letters, so you should be careful about what you are writing here. And in your exam, they will not tell you just find ddx of this or ddx of that. They will ask to differentiate on some other word problem we'll see in our next lecture. But today, this one, be careful that you need to understand what is changing depending on what. X is changing on depending on y, that's why we write ddy of x. And here y is changing depending on x, so we write ddx of y. You can rewind it multiple times and be clear about that. Now let's solve this. So what we do is we differentiate each one of the terms using the power rule. What happens there? We just write what we have, then we bring the power in front, then we write the variable and reduce the power by 1. That's it. That's the simple part. Now again, we have 17 by 4. We bring the power in front, we write the variable and reduce the power by 1. Again, the same thing. We write 16, 2 comes in front, we reduce the 2 by 1 after writing the variable. Now, the last one, as I said, if you remember, the last question, we do not have any variable. Ultimately, it's going to be 0, so we don't need to write it. We don't care about it. If there is no variable, it's just gone. Okay, now let's see what happens. See, we can simplify here. 3 and 9 will give us 3. So minus 3 multiplied by 8 is minus 24. Now, when you reduce minus 9 by 1, you get minus 10. Okay, plus, we cannot simplify here. We cannot do anything. So 17 multiplied by 3 is 51, divided by 4 and y squared, right? 3 minus 1 is 2. Plus 16 multiplied by 2, we have 32, no fraction here, and y is power 1, we do not need to write 1. And just like that, you have solved the hard part, you have solved the bigger maths too. That's it for today. In our next class, we are going to see how the power rule can be applicable in real life situations and in word problems. I think you like this video. If you are clear about it, do not forget to like and subscribe. And I have a playlist for IGCSE chemistry. If you want to check out that playlist, you can just click on the icon there and it will take you to there. See you in our next video. Thank you.